All right, so we're going to do some derivative practice this morning. You got this new product rule, but here you have this binomial times this two-term thing. They're not binomials, but two-term things multiplied by each other. Don't do the product rule. Multiply it out. You make so I can rewrite this. Listen, if I multiply this out, I sure hope you guys get this. And how easy is it to take the derivative of that green disaster? Pretty easy compared to doing the product rule, which would make this F and this G, and then you do F G prime plus G F prime, right? That's a big disaster, and who would want to do that, right? So here I go. Y prime for the first one. 3u squared plus 2u plus 2u negative 2. Boom. So first thing, every time you get a derivative function, if you look at it, you should decide, can I simplify to something more, friendly? This, if I do the product rule here, guys, I can do this. I can do this as, I can do f prime g plus d prime f, okay? And call the first one, and you'll get the same exact answer after a ton of work. Always try to simplify first. So with that in mind, let's try
one that you actually have to use.
Well, not the product rule, that's for sure. So let's try this one. I'll pause it for recording. So again, the second one here, you could think to yourself, I want to do the quotient rule. And I could call all of this f of v. And I could call the whole bottom g of v. And we could do the big long quotient rule, right? Which we learned yesterday. That g of v times f prime of v minus f of v g prime of v all over gv squared. That's a lot of work. Especially when you can factor a v out. And I skipped a step here. What I want you to notice is I changed the radical of square root of v to v to the half. Boom. They cancel. Now, if I look at y prime is a whole lot easier. Derivative of 2v, or v squared is 2v. 1/2 times 2 is 1, so negative v to the, and half minus 1, so what, negative half. And that is y prime. All right. So now we've done two where you see that you can do the simplification, right? So the question then becomes, what about the next one I put on the board today? Let's all agree before you start. Can this be simplified? No. It cannot. One does not have an x. This is not simplified. You'll have to use the quotient rule. So we have to remember that and we remember that if you have two functions and you want to find the derivative of those two functions, I'm going to write just like the book. So the way I do it. All right, so everybody try this, all right? All right, so if I look at this function, and remember, this red f here is not the same f as here, right? So what this really means is I have a function f of x, but I want to think of this as f of x over g of x. So that means in this case, f of x is x, and g of x is x squared minus 1. All right? And if I use the quotient rule now, if I use the quotient rule and I extend the page, get it all centered, does everybody agree that f prime of x using the power rule is just 1? And g prime of x using the power rule and the sum rule is just 2x. 2x plus 0. Now you just got to fill in this equation with it, all right? So here we go. So they get f prime of x equals g is x squared minus 1 on top. F prime is 1 minus f is x. G prime is 2x. All over the quantity x squared minus 1 quantity squared. Now, we do not have to square the bottom. You can leave that because everybody see the top becomes x squared minus 1 minus 2x squared. All over x squared minus 1 squared. So I get negative x squared minus 1 over x squared minus 1 squared. And guess what I just found? F prime of x. What good is this? What does it tell us?
Nothing.
It tells you the slope of the tangent line at x, any value of x. It tells the slope of the tangent line at x. So actually, we really want to be able to apply this. All right, so if I copy this, so we can take it to the next page, really, I want to do this. I want to find the equation of a tangent line of a function at x equals 2. Well, if I tell you this rational function, if you're going to find the equation of a tangent line, you have to find the slope. So you're going to have to do the derivative. You got to say it nice and loud so I hear it. All right.
Derivative.
There we go. All right, so now let's actually use the quotient rule and find a tangent line. And I'm not going to label, but the top is f of x, the bottom is g of x. So here we go. F prime. G of x is x plus 7. F prime is 2x plus 1. Minus. F is x squared plus x. And derivative of the bottom, I was nice to you guys. X plus 7, derivative of x plus 7 is 1. All over quantity x plus 7 squared. Now, does it ask you in the assignment here to find the derivative? The answer is no. So here's where I'm at. I need the slope and I need a point. I'm not going to overthink this. I am going to not simplify. I'm just going to stick 2 in right now. 2 plus 7 is 9. 2 times 2 is 4 plus 1 is 5. Minus 2 squared is 4. 4 plus 2 is 6. 6 times 1 is still 6. All over 2 plus 7 is 9 squared. It'll be 81 on the bottom. 45 minus 6. Everybody, you should have got 39 81s. So I have now found the slope. I also need a point. How do I find the point? Well, I have the original function right here. So I have to find the y value. All right. Oh, 39 81st, it does reduce. You're right. 13/27, doesn't it? All right. I will now find f of 2. Put 2 in. I get 6 on top over 9, which reduces to 2/3. Everybody, at this point now, I have a point and I have a slope. And we're going to learn point slope form. If it kills us, y minus 2/3 equals 13/27 times x minus 2. There is the equation of the tangent line at 2 of that rational function. All right? All right.
Someone died.